Well, hello there, everybody. This is our third unit, and we're going to be working with three standards this unit. This is the first, so our first video. And our first standard, go ahead and write this on the top of your paper, is to determine the solution set of absolute value equations and inequalities. So before we can actually determine solution sets, we probably should define absolute value. So that's what we're going to do. Take a moment and pause, make sure you've got that written down at the top of your paper, and then proceed, and we will get to learning. So we're going to start with the definition of absolute value. And here's our absolute value definition. Very simple. The distance of a number from zero. The distance of a number from zero. Another way to say this, and this is a different way to kind of get our head wrapped around it, okay, is the distance between a number and zero. The distance between a number and zero. Oops, sorry. Okay, so this is another way of phrasing what absolute value is. So if we were to look at the absolute value of 3, we're talking about the distance between 0 and 3. The difference between a number and 0. So what is the distance between 0 and 3? We say, well, the absolute value is 3. So the absolute value of that, the distance between 0 and 3, is 3. Well, what is the absolute value of negative 3? Well, it still is phrased as the distance between 0 and negative 3. So that absolute value is also 3. We can show this on a number line, that the distance between 0 and 3 to this spot, I don't use arrows because it's not going on forever, but the distance between 0 and 3 is 3. The distance between 0 and negative 3 is also 3. All right, let's keep going. So there are a few properties of absolute value, and we know that absolute value of any number A, okay, any real number A, is greater than or equal to 0. Okay, so this is representing that it must be 0 or positive. We also know that the absolute value of negative A equals the absolute value of positive A. This means the absolute value of a number and its opposite are the same. So the absolute value of a number and its opposite are the same or equal. Okay? We also know that if we take the absolute value of A times the absolute value of B, we could simplify that by doing the absolute value of A times B. This works. Let's think about why that works. If A and B are both positive, so a positive times a positive inside absolute value, will not change it if you move a positive times a positive and take the absolute value. Consider that with negatives now. If I have the absolute value of a negative times the absolute value of a positive, this is going to become a positive number. This is already a positive number. So would it matter if I multiply a negative times a positive and then take the absolute value? No, of course it will not. So we can say that the absolute value of A and the absolute value of B, if we multiply them, is the same as just taking the product and then the absolute value. So in this case, that grouping of the absolute value does not affect anything. Another one, this is very similar to the last. The absolute value of A divided by the absolute value of B would work out the same as if I just did the absolute value of A divided by B. As long as we have here B cannot be 0, and we know why B cannot be 0. So this works the same way as the multiplication did. Let's consider, does that work? Does this apply for addition or subtraction. Okay, so if I have the absolute value of A plus the absolute value of B, does that equal, it's a question mark, does that equal the absolute value of A plus B? I want you to think about it, draw your own conclusion. I'm not actually going to give you the answer because it's part of the practice set. All right. Now we're going to take a look at evaluating some absolute value expressions. For this, I'm going to use x equals -6 and y equals +10. I'm going to give you two expressions and we're going to evaluate them. So I'm going to have the absolute value of 2x minus 3y. This entire quantity is in the absolute value, which means we have to work within and then do the absolute value of it. It's like it's a grouping symbol. I must use it as a grouping symbol. I have to take care of what's inside, kind of like parentheses. But they're not parentheses because I have to apply the absolute value operation. So we'll start by substituting the numbers, and that means I have 2 times -6 minus 3 times 10. We'll simplify within, which means that this is the absolute value of -12 minus 30. I'll simplify within, which means the absolute value of -42, and now I apply the absolute value and get 42. Let's try one more together. This one is going to be 2 times the absolute value of x minus the absolute value of 3y all over the absolute value of x times y. I'm going to go ahead and take a moment, try it on your own first, pause the video, and then you can fast forward through my work or you can check with me, but I'll go ahead and give you some time to do that. Alright, so you should have already tried it, but let's just go through it really quickly here. I'm going to fill in the numbers. I've got 2 times the absolute value of -6 minus 3 times 10 inside the absolute value over the absolute value of -6 times 10. As we simplify this, this turns into 2 times 6, it's +6 because it's the absolute value, minus 3 times 10, the absolute value that is still 30. And the denominator, since this is -60, but it's the absolute value, it's a +60. If we continue to simplify, I have +12 minus 30, which is -18 over 60. And you can go ahead and reduce that value by dividing them both by 6. If you divide them both by 6, I get 3 over 10, and it is negative. Okay? All right, so go ahead and try the entrance slip on Schoology. If you have any questions, post them on the updates page so we can answer them together, and we'll get to practice in class.